So today we are solving this problem, directed graph cycle. So in this question have given a vertices 4 and the edges. So first we have to convert this into adjacency list. Adjacency list. Okay. So let's convert this. So at 0 index we have 0 to 1. We can reach from 0 to 1. So we'll create an array here and 1. Any other value from 0 we can reach this one done. Then at 1 we can reach 2. So at 1 index we can reach 2. This is our adjacency list. Okay, then we can from 2 we can reach 0. So from here we will write 0. Then from 2 we can reach 3 as well. So we have to update this value 0 and we can reach 3 as well. So this is the value. This one is also done, this one is also done. Now this one we can reach 3. Sorry, this array is gonna be empty because from 3 we cannot reach anywhere. This because this is a directed graph, direction is already given here. So this kind of adjacency list we have. Adjacency list. Okay, now next problem is we have to find or detect the cycle. We have to find and detect the cycle. So to detection of cycle, we cannot just rely on visited array. We cannot rely on only on visited array. We have to take one more variable called recursive stack. Recursive stack. What it will do that it will keep track of the cycle. So cycle in the sense that let's suppose that we have this cycle 1. From 1 we can reach 2, and from here we have 0, and from 0 we can reach 1, and from 2 we have this. Okay, so we have this cycle. Okay, so we'll keep track of in our recursive cycle that for example we have this our recursive stack. We will put 0, 1 and 2. Okay, let's make this empty here. Now let's start iterating our loop. We will start from 0. We will make 0 true. We will reach now 1. We will make 1 true. Then we will go to 2. We will make 2 true. And then from again from 2 to 0 we can see here that we again reach the same position. Okay, so now what we have here cycle, because this is a true. So in single cycle we have all the values are true, which means we can return from here true, that yes, cycle exists. Let's try some other cases as well. For example, why you should use this array recursive stack. Let's say you are not using this. Okay, and you are only relying on visited array, only visited array, and we have this example 0. From 0 you can reach 1, and from here we have 2, and from 2 you can again reach 1. Okay, we have visited array 0, 1 or 2. Okay, from 0 we will start from 0. It will make 0 2. We are visited that. We will reach 1 here. From 0 to 1 we will reach 1 here. We will make 1 2. Now here our first iteration will stop. Now next iteration what will happen, we will iterate from 1, then 1 is already visited, so we will not do that. Then we will reach till 2. So our loop will now check for all the adjacency values of 2. So from 2 we again reach 1. We'll make 2 first true. We are visited this. Now we try to reach again 1, but you can see here that 1 is already true. So if you rely on visited array, it will return true. It will return true, which is not exactly the right answer because there is no cycle here. Okay, that is why we need another variable called recursive stack. Recursive stack. Okay, so let's again try one more example. What should we try again? Let's try this 0. We have to create one cycle first. 0, then 1, From 1 we can reach 2, and from 2 we can reach again 0. Okay, and let's remove the cycle now, and we have this array. From 2 we can reach again 0. So this is our cyclical graph. Okay, let's try this on this one. So we have recursive stack here, 0 1 2. We have visited array here, 0 1 2. Okay, now let's run again with our trick. So with our logic, we will from 0 we will start, we'll make 0 true, we will go to 1, we will make 1 true, then from 1 we cannot go anywhere, there's no direction here from 1. So what we will do, we will skip this value. Now we go, our iteration will start from 2, so we will reach 2. Oh sorry, let's do it again. Actually we didn't updated our visited array, we are just updating our recursive cycle. Let's try this again. We will start from 0, make it true from both sides. This is our first cycle. Okay, 0, then we'll reach 1, we'll make recursive cycle true, visited true. Now here we are stuck, that we cannot move anywhere, there is no direction from 1, there is no direction from 1. Okay, so what we will do, we will update our recursive cycle. There is no cycle here, so we'll update it. Now it is again empty. Now we will start from 2. Let's update 2 recursive cycle 2 true, and let's update here again 2. Now from recursive cycle from 2 we will reach again 0. So direction here, right? Wait, now it is a problem here. This is a wrong graph actually. This shouldn't be like this. हाँ. Let's update this graph properly. Now we can reach from 2 to here, and we can reach from 0, we can reach 2 as well. Now we have a cyclic graph. From 0 you can reach 2, 2 from 0 again you can reach 0. Let's try this again one more time. Okay, now we have 0 graph, 0 value, we will reach, make 0 true, and recursive cycle make true. We can choose any direction, but let's choose 1, make 1 true, 1 true. Now from 1 we cannot go anywhere, so we will, there is no cycle here, so remove this cycle. We will now start our new cycle. New cycle in the sense that we are looping through a different array. Now we will reach 1. Our for loop in which we are calling our DFS function will iterate to 1. It will see that in 1 we already visited, it is already true, it is already true. So what it will do, it will skip this. Now it will reach 2. Okay, now after reaching 2 we will make this true, and the recursive cycle is also true. Okay, after this we have adjacency list. So from this 2 we will call this 0, it will call this 0, so this recursive call is true. Okay, now this 0 again will call what, 2, and we will again check our recursive stack. Oh okay, so you look at here, we have returned true, which is already 2 is already true, which means we have now found a cycle. So we will return a true from here, return a true from here. Okay, so let's try to get this done again. Let's try to do this with some other test case as well. What kind of test case we write? 0, from 0 you can reach 1, from 1 you can reach 2, and from 2 you can go to 3, and from 3 you can go to 0. So in this we have cycle. Okay, or let's make it a little complicated. We can make it a little complicated here. From 3 you can reach 2, make it directed graph. From 3 you can reach 4, and from 4 you can reach 2. Okay, so again in this loop we can directly see that if it move to 0 to 1, this is a first cycle. From 1 first cycle we are not stopping anywhere. From 1 to 2, from 2 to 3, 3 to 4, and 4 to 2. In single cycle we are moving continuously, and we find this value which is already visited, so we'll return true. Okay, so let's write first a pseudo code for this, and then we will see our code, write our actual code. So how we will start, let's suppose that we have a function called here cyclic function. Okay, this is our cyclic function call. Start from here. We will define, first of all we have to convert adjacency list. So let's convert into adjacency list. Okay, we have edges, so we will create an adjacency list. Okay, so we will create adjacency list here. Adjacency list. Now on this we have to run our loop, but before that we will call two values. First is visited array, so we'll initialize with false value. इसकी this his length gonna be or we are already getting vertex, so we'll multiply this vertex. So our code will like this, multiply with vertex in Python. Okay, then we have recursive stack. We again will call this false and vertex. They are both similar. Now next we'll run our for loop. So we'll start our for loop from 0 index till we run our from vertex. So if vertex value is 4, our loop will run from 0 to 3. Okay, so this will run from 0 to 3. We have to check if our array is visited or not first. So we'll check is visited. Consider that this will return whatever value is visited, and we have to check. Then we have to call DFS function hour. Then we will pass adjacency list. Okay, then we will pass visited value. Then we will pass recursive stack, and we will pass another value which is our current loop in which we are running. So we'll pass I here. Okay, and consider that this function is returning true if we found any cycle. Okay, so this function is returning true if we found any cycle. I will write here returning true if have any cycle. Okay, if have any cycle. If it is returning there is a cycle, we already find cycle, then we'll return from here true. If there is no cycle till this function didn't return any cycle, then we will simply return false from here. Okay, so this is our first function. Now let's complete the DFS function, which is our main logic. So let's write this. We have DFS. Okay, we have values. Let's see what values we are passing. We have adjacency values, we have visited values, we have our recursion stack, or we have our edge, or we can say our node in which we are currently are. Okay, now let's check. First of all, we have to check that if recursive stack has true value of current node. So if recursive stack has true value of current node, then return true. Okay, this is done. Now again we have to check one more condition. If visited array has one more value, which is if we visited already, current node is already visited, then we will return, but here we will return false, that don't need to come here or check any further. Okay, that's it. Now if both the conditions are not true, then we're gonna make visited current node as true, or recursive stack of current node also true. Got it? Now we will run our loop. So we'll for edge, so all the edges we have in our adjacency list. So in our adjacency list we'll get all the edges of node. So it is going to be something like, our array is something like this, right? So we are getting the looping through this portion of array, suppose. So we'll call if dfs, we will pass again all the values. So we are considering that it will return our value, which is our recursive function. So we'll call again this function and pass all the same values here. Same values. We'll just change our node adjacency value, adjacency list, visited one, then our recursive stack. But here we, instead of node, we will have to update our node value, which is our edge. Okay. Now if this dfs function returning true, then we will simply return true. Okay, but if this loop is completed and there is no value, if this loop is completed, this one, let's draw this, then there is no cycle, correct? So what we will do here, we will just make recursive stack again false, that we didn't find any cycle, reset it again. Okay, so, or at the end we will return false, at the end we will return false. Got it? So now let's write this pseudocode in actual code now. So let's write it. Let's start with our first case. We will return our adjacency list for I in range based on vertices. We'll create our adjacency list. Now we have edge edges adjacency list edge 0 dot append edge of 1. Got it? Then visited, we could have visited array initialize with everything with false. Same recursive stack, initialize everything with false. Then our for loop, for I in range b. Now if not visited, if not visited, and DFS same cheese adjacency list I visited and recursive stack. Okay, this we are suppose that it is returning true, then we will return true. At the end it will return false. Now I always get confused, like what is this loop for and what is the inner loop for. So this loop is for outer loop. Let's see what this I mean outer loop. So as you can see here, when we create an adjacency list now, so we have two arrays like this. One array, we have some value 1 comma 2 comma 3, then 1, then comma 1, then comma 2, then comma 0 comma 2, something like this. So our first loop, this loop which we are running, is our main array. So what I mean main array is that this outer array, we have, this is a, we are running first from here, and when we're gonna write our DFS function, we're gonna run each of this, first this, then this, and then this. So it is gonna be in DFS inner function call. Okay, so this is gonna be a second loop which we're gonna run. So now again let's go back to code. Now let's finish our DFS function now. Def DFS adjacency lead, we have our node which we are, then we have visited, then we have recursive stack. Okay, now first thing what we have to do, if recursive stack is true, which means we are in cycle, so we'll return true. Now if visited, we already visited current node, then we'll return it from here, but we'll return false. Now if we are visited this node, then make it true. Same, we have to make recursive stack also true. Also true. Okay, till here now we are running each node. Okay, so we'll call for v in adjacent list of current node, then we're gonna run same function if DFS adjacency list vertex visited and recursive stack. If it is true, then return true. Now when we run our one cycle and we didn't find anything from this loop, which means there is no cycle here, so we'll reset our recursive stack to start with for our new cycle. We'll make it false. We'll make it false, and at the end we'll return false. Now let's try to run this, and it is, we have some error. And what is error? Main is cyclic if not visited. So what is the error here? Adjacency list I visited, recursive stack we have. Okay, spelling mistake here. So the test case are passing. Now let's submit this. And yes, it is working perfectly fine.